Obtain the mathematical model of system shown in figure. Here, three masses are there. M1, M2, and M3. And finally, obtain the electrical force voltage analogy of given mechanical system. And hence find force voltage analogy of given system. Here, what are the forces acting on M1? Because of K1, because of K2, and FV1, FB1, or simply B1. These are all dashpot coefficient, frictional coefficient. Sometimes they will put like this. That's why I took this out. Because of frictional force, this dashpot effect will be there. That is mentioned as FV1. Here FV2. Between two masses also that is mentioned. They mentioned FV3 and FV4. The displacement of mass 3 is x3. This is x3. Displacement of mass m1 is x1. So what are the applied force? Applied force is on m2 only, f of t. Now, if you draw the free body diagram for m1, displacement is to its right. F, no force, no applied force. Displacement is x1 to the right. Therefore, reaction forces are acting from right to left because of F, M1, because of K1, because of K2, and because of FV1, of course, because of FV3. These are the 5 reaction forces acting on M1. Fm1 is M1 d square x1 by dt square plus Fk1, one end is fixed. Therefore, K1 x1 plus K2, both ends are free. Displacement at this end is x1, displacement at this end is x2. We are writing in terms of M1, therefore, K2 multiplied by x1 minus x2. Here, the friction is between floor and the mass M1. Therefore, one end is fixed in this case. Therefore, plus FV1 d upon dt of x1. That's all. But for FV3, between M1 and M3, the displacement in M1 is x1, displacement in M3 is x3. Therefore, d upon dt of x1 minus x3. How many forces? 1, 2, 3, 4, 5. That's all. Equal to 0. Therefore, no applied force. Similarly, if you write for M2, d square x2 by dt square plus because of K2 x2 minus x1 because of FV2 d upon dt of x2 plus because of fv4 d upon dt of x2 minus x3. How many forces? Because of m1, 2, 3, 4. That's all. 4 reaction forces. 1, 2, 3, 4. Applied force is f of t. That's all. Then for m3 d square x3 by dt square plus no spring, only dash part. Dash parts are fv3 and fv4. That's all. Therefore, no applied force. So fv3 d upon dt of x3 minus x1 plus fv4 x3 minus x2 equal to 0. No applied force. Only 3 reaction forces. Only 3 reaction forces. Now we got the mathematical model of given mechanical system in time domain. That's all. These 3 equations together represent the given mechanical system. I took this sum because of 2 reasons. One is to explain FE1, FE2, FV3 and FE4. Frictional coefficients can be taken as dashpot coefficients. That is one thing. Another thing is here the electrical system will get some difficulties in uptake. That's why that we will see now. How to convert this into force voltage analogy. For that, what we have to do is we have to take L1 force voltage analogy. L1 d square q1 upon dt square plus k equal to what? 1 by c1 q1 plus 1 by c2, 1 upon c2 q1 minus q2 plus fv1. fv1 is b. B should be taken as r v1 or r1 simply r1 dq1 upon dt plus r3 d upon dt of q1 minus q3 equal to 0. For second equation, L2 d square q2 upon dt square plus k2 1 by c2. 1 by c2 already we returned in the previous equation. We have to reverse that. q2 minus q1 plus fv2. fv2 is r2 dq2 by dt plus fv4. fv4 is what? r4 d upon dt of q2 minus q3 equal to v of t, applied voltage. Here we can write for third equation L3 d square q3 upon dt square plus fv3 is r3 d upon dt of q3 minus q1 plus r4 R4 already we wrote. We have reversed that. Q2 minus, sorry, Q3 minus Q2 d upon dt of Q3 minus Q2 equal to 0. Now we can write all these equations in terms of current. We wrote in terms of charge. We know that I equal to dq by dt. Replace in terms of current. What you will get? The first equation is L1 d square, sorry, di1 by dt plus 1 by C1. Q equal to what? I equal to dq by dt. Therefore, Q equal to integral of I dt. Therefore, 1 by C1 integral of I1 dt plus 1 upon C2 Q1 minus Q2. Therefore, 1 upon C2 I1 minus I2 dt. I1 minus I2 dt. R1 dq by d is I1. Therefore, plus R1 I1 plus R3 I1 minus I3. R3 I1 minus I3 equal to 0. 1, 2, 3, 4, 5. This is first electrical equation. For second, L2 di2 upon dt plus 1 upon C2 I2 minus I1 dt plus R2 I2 plus R4 I2 minus I3 R4 I2 minus I3 equal to V of t. This is second equation. Third equation, L3 di3 by dt plus R3 I3 minus I1 plus R4 I3 minus I2 equal to 0. Only 3 forces acting on it. This is third equation. Now we have to draw the equation. You see that in the first equation, I1 minus I2. Therefore, first loop and second loop are adjacent. In the same first equation, one more I1 minus I3. Therefore, first loop and third loop also is adjacent. Here, I1 minus I2, first loop and second loop. I2 minus I3, second loop and third loop also adjacent. First and third, second and third. Here, I3 minus I1. First loop, third loop and first loop are adjacent. I3 minus I2. Second loop and first loop are adjacent. But anyhow, if you see that first loop and the second loop are adjacent, no problem. That is already we have seen such type. This is I1. This is I2. No problem. I1 minus I2 automatically you will get. We need I1 minus I3. Therefore, it should be adjacent to first loop as well as second loop. Here you will get I1 minus I3. Here Here what you will get? I3 minus I2. I3 minus I2. I3 minus I2. I3 minus, here you will get I3 minus I1. Or I1 minus I3. Here I2 minus I3 you will get. So this is the problem. If you take the loop like this, you can finish. This is the crucial point. That's why I took this sum. So L1 is in the first loop only. Therefore, we can draw L1 here in the first loop only. R3 is between I1 and I3. R3 is here. C1 is in I1 only. C1 is in I1 only. C2 is between I1 and I2. C2 is between I1 and I2. R1 is in I1 only. R1 is in I1 only. We can put it here. R1 is in I1 only. 1, 2, 3, 4, 5. That's all. If you take second loop, L2 is in I2 only. So we can draw L2 here. C2 is between, already we have drawn, C2 is between I1 and I2. R2 is in I2 only. R4 is between I2 and I3. Therefore, R4 must be here. How many? 1, 2, 3, 4 elements. Yes, 4 elements are there. We can finish. But one thing is pending, that is V of t. That is in this loop only. So V of t is applied here. V of t. So the capacitor, I have to remove this. Some line is there. Be careful. Okay. This is capacitor, remarked. So you can mind those things. L3 is in third loop only. L3 is in third loop only. We can draw here L3. R3 is between third loop and first loop, already drawn. R4 is between second loop and third loop. That's all. That's all. This is electrical analogous of given mechanical system. Force voltage analogy. Do it yourself. Force current analogy. Assignment number question 1 is find the current analogy.